sign it. All right. It's a terrible thing when it logs you out in the morning.
Do you have a copy for cord I could use?
Right there. Go ahead and use them.
Do you have a cord sometime near outlet?
No, I don't. Those are the only things I have. They do not give us extra cords for you guys. All right, ladies and gentlemen, as we get going, a couple of reminders real quick. Number one, please put away your cell phones, your headphones, those electronic devices so that they are stored and out of the way for the class period. Number two, we do start the tardies today. So if you are tardy, they start keeping track of them. If you get to 4 tardies this week, next week, Tuesday, you'll be assigned to lunch detention. So please make sure you're getting to class on time or you've got to pass. If a teacher stops you in the hall or talks to you or whatever, make sure you get a pass from them so that you're not late when you get to class. Okay? Hope you had a good 4-day weekend, ladies and gentlemen. Mine was only 3 days, but it was still pretty good. Okay? So today we've got a bunch of stuff to do. We started talking about accuracy and precision right at the end yesterday. I also am going to go back and I'm going to do the last 2 problems on the metric conversion worksheet, show you a little trick to do with those, ladies and gentlemen. But first of all, what's the best candy? What is the best candy, ladies and gentlemen? Go ahead, fire away.
Sour Patch.
Sour Patch? Not a big fan of those, but okay. All right, Sour Patch. All right, what else?
Reese's Pieces.
Reese's Pieces. No, those are terrible. That's an M&M knockoff, and they're not even that good. But it's okay. You can go with it. That's all right. I don't mind. What else?
Reese's Take 5.
Take 5?
Yeah,
What's that?
Reese's Take 5. Like a Reese's with perfect caramel.
Okay. All right.
Are we talking about chocolate? Or
Whatever. Candy. Whatever you would consider candy. Skittles? You know what I learned last year asking this question in my class? You're not supposed to just swallow Skittles. I never knew that.
What?
I always thought Skittles had no flavor. Then they told me, what are you kidding? They have all kinds of flavor. I said, every time I swallow them, I never taste nothing. They're like, you swallow Skittles? I didn't know.
But why would this be your first thought? I should just.
Well, it's like a pill,
Did you
right?
hit your head?
No.
What?
Did you hit your head?
Multiple times when I was younger. Why? Oh, okay. Skittles.
What else do you just swallow? Why specifically Skittles?
I don't. They remind me of like an aspirin or a pill, so I thought I'd.
Do you swallow M&Ms?
No, because those I get the peanut ones, so I know there's peanut inside there. Don't try to make sense out of me. It's almost an impossibility, Abby. It won't happen. It won't happen. All right, what else? You still haven't hit the best candies yet. No. Oh my gosh. Don't give me that. By the way, Twix's advertising campaign is completely wrong.
What?
What's their advertising campaign?
Left or right?
Left or right? Well, when you hold a Twix bar up so you can read the label, which way do you hold it? There's not a left and right. You don't hold it like this. You hold it like this, which means there's a top and bottom Twix. Their whole advertising campaign is wrong.
Why are you holding up the
Because you read the label then. The label is written so that it's long way. not up and down. Hello, so sign in, please. Okay, I'm not a big fan of Twix, sorry. Nah. You guys still haven't hit the best ones yet. Come on.
Were you gonna say something basic like Snickers?
Yes! Snickers, pretty good. Top 5. Top 5. Okay? Let's keep going. We're going. We're good. We're
Three
good.
Musketeers.
Oh, no.
I like nerds.
What?
I like nerds.
No. No. But, okay, that's fine.
I am not
That's
taking
fine.
advice from that who swallow skills.
Okay, I'm not asking you to take advice from me, but when we get to the top 5, you're going to be impressed. Okay, come on.
Tootsie Roll. That's Tootsie Roll.
Tootsie Roll is a good standard, but I don't consider it a great candy. It's-
Milky Way.
What?
Milky Way.
No.
Circus
no, sorry.
peanuts.
What? Oh, God, you might as well eat the peanuts that they pack stuff in when they ship it in a box. Oh, my gosh.
You were a clown. Shouldn't you like them?
I was not a clown, Jules. I went to clown school for a year and a half and didn't make it. Let's not go there. Okay? Come on.
I can
Best
do those
candy.
animals.
Best candy. Snickers, you got one of the top 5. We mentioned the brand for another one of the top 5, even though you didn't measure the candy. Jules mentioned it, by the way.
And there's a Reese's.
Reese's Peanut Butter Cup. Come on. Chocolate,
Yes.
peanut butter, both good. You put them
Yes.
together, you get greatness.
I
I mean,
agree.
come on. Come on. That's a top 5. All right. Anybody else? Number 1, ladies and gentlemen. Number 1, Swedish fish. Swedish fish. Number 1. Okay. And the best part is, when I was a kid, they didn't have them in the little packages like they do now. They had the big box with all the little ones individually in it. After a baseball game, I would go up and I would buy $5 worth of Swedish fish, and they were a penny a piece. Those ladies hated me at the concession stand because they had to count out 500 Swedish fish and put them in a bag for me. Okay? Now, another good candy that's gone nowadays, you guys probably never heard this. You ever hear of flying saucers? Flying saucers. They're 2 wafer discs. They look like a little flying saucer. 2 wafer discs with little candy in the middle. It was all just sugar pieces, basically. Okay? Okay? So again, not bad. You came up with a few good ideas, but again, you know, Reese's, Snickers. Oh, can't forget Nestle Crunch. Nestle Crunch, definitely in the top 5. Why are you shaking your head no after you told me nerds?
Because that's gotta be the most basic chocolate.
With crisp rice in it. Crisp rice in it. That's good stuff.
You might as well say Heath Bar.
Ooh, Heath Bar. That's another good one. Although the toffee in there kind of sticks to your teeth forever. Okay? I think I still have one from 1997 that I ate, you know? So, how old was I then in 1997? 27. You do the math now. You know, there is something that is worse than getting older. You know what it is? Death! Okay, so I get older every day, and I'm proud of it. Proud of it. So, all right, ladies and gentlemen. All right, let's get some work done. So take out your packet and let's start there. Let's look at the last 2 problems on the conversions in the packet that I gave you the other day, ladies and gentlemen. Okay? All right, so these are the last 2. They are U and they are V. Now, what I need you to understand, there is no way that anyone can memorize every conversion that there is out there. Okay? There are literally millions of different units. You can go from just about any unit that measures the same thing to any other unit that measures the same thing. Okay? So in other words, if you're talking about distance, there are conversions out there that will take you from kilometers to miles. There's a conversion out there that will take you from feet to inches, inches to meters, inches to centimeters, all kinds of things. Now again, if you have a job someday where you need to make conversions or things, you'll learn certain things, okay? So I've been teaching chemistry for 27 years, and I've learned certain conversions. 2.54 centimeters equals 1 inch, okay? 1,760 yards, or I'm sorry, 1,760 yards equals 1 mile, okay? So you may know conversions, and you may be able to do these problems in a simpler way than what I am showing you. And as long as what you are saying is equal to something else is correct, you can use different conversions even than the ones I give you. That is absolutely fine. The problem is you can't say 10 decimeters equals 1 centimeter because that is not a correct conversion. So if you're going to say two things are equal, they have to actually be equal for you to use them. Otherwise, you're not going to come out with the right answer. Okay? Now, I have never given you this relationship before. I gave you decimeters to meters. I gave you centimeters to meters. Understand, I could give you something like this. It's a matter of can you use it. And to use it, you use the method that we taught you, which is you want your units to cancel. You want the unit on top to cancel with the unit on the bottom, so you move into a different unit. But this gets a little bit tricky because in science, in chemistry specifically, we measure volume often. Now, again, if it were an object like this desk, and we wanted to find the volume of this desk, we would take the length times the width times the height. And that is how you find volume, okay? Length times width times height. Well, we often find the volume of liquids in this class as well. And the volume of liquids are normally measured in liters or milliliters. However, there is a way to convert from liters and milliliters into a way of measuring by length times width times height. We'll get into that in 1 second, okay? But also, when you do length times width times height, you get a unit that is cubed. So if you take meter times meter times meter, you end up with a unit of meters cubed, okay? Sometimes you find area. You take length times width, you end up with a square unit. So sometimes we need to find a way to convert from one unit to another, and they may be cubed units. So I'm going to show you a trick today to do that, okay? Now, to finish this problem out, you are going to need two other things that are not listed here. Because we are eventually taking this conversion and we are going into so many liters, that's what was asked of you. You're going to need these two conversions. 1,000 milliliters equals 1 liter. And you're also going to need this conversion. 1 cm cubed equals 1 milliliter. Okay? All three of these things, 1 milliliter, 1 cm cubed, and 1 cc, mean exactly the same thing. Okay? Milliliters we use when we're measuring volume of liquids or gases. Cubic centimeters we use if we are measuring a dice or some solid object. We will normally do it in cubic centimeters where you measure it with a ruler. Anybody know what they use cc's for? cc's is used in the medical industry. So on a medical show, they may say, give them 10 cc's of this medicine. What it means is give them 10 cubic centimeters or 10 milliliters of it. Okay? Also, they use cc's in motorcycles, ATVs, snowmobiles. The size of the engine, they will measure them in cc's, 150 cc, 250, 350 cc engine. Okay? Point being, all three of those mean the same exact thing. Okay? The same exact amount. Okay? Now, the one thing that we have to do, though, is get this dm cubed into cm cubed to be able to use these two things. To do that, we are going to use a trick. We are going to take and we are going to have a conversion factor like we have here. And we are going to take and we are going to cube the entire conversion factor. The whole thing. What that means, ladies and gentlemen, is I'm going to take and cube 1. I'm going to take and cube decimeters. I'm going to take and cube 10. And I'm going to take and cube centimeters. Now, cubing a unit is easy. You just put the 3 after it. The one thing we have to be careful of is we also need to cube the numbers here. And what happens is, what's 1 cubed? 1. Decimeter cubed is 1 decimeter cubed. people see this and they think, oh, you don't have to do anything with the number. No, you've actually cubed the number 1. It's just 1 times 1 times 1 still only gives you 1. Okay? So when we look at this here, this part, this becomes 1 decimeter cubed. Now, what do you get if you cube 10? You get 1,000 centimeters cubed. Okay? So that's the one thing. People forget to cube the number that is 10, 100, or 1,000 when they do this conversion. Okay? So now that I have done that, ladies and gentlemen, I'm going to use that, and that is going to be the first step in this process. So which part of this, the 1 cubic decimeter or the 1,000 centimeters, what goes where? What goes on the bottom? What goes on the top? Decimeter has to go on the bottom because it's the only way the units will cancel. And it's actually, I'm sorry, I said a decimeter. I should have said decimeters cubed. Okay? So that now this decimeter cubed and this decimeter cubed cancel out. That means the 1,000 centimeters cubed goes on the top. We've now gotten out of decimeters cubed and we're in centimeters cubed. Again, remember, we're still trying to go to liters, right? So now I need a way to get from centimeters cubed into something like liters or milliliters. That is this step here. Okay? So the next step, which part of this goes where? What goes on the top? What goes on the bottom again? One centimeter cubed on the bottom. 1 milliliter on the top. Now you may be looking at this and going, Mr. Brand, why are you bothering? This is just 1 over 1, right? But it is changing our units, which is what we want. We want to continue to change our units until we get to the 1 that is our final unit. Okay? So now, ladies and gentlemen, this cm cubed that was on top cancels with this cm cubed that was on the bottom. Fair enough? Okay. So last step, ladies and gentlemen, is now we're going to use this one to get from milliliters to liters. What has to go on the top? What has to go on the bottom? Don't everybody shout out all at once, please. Somebody. 1 milliliter goes on the bottom. Only way it'll cancel out. 1,000 milliliters on top. Whoa, 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 whoa. Thanks for correcting me there. 1 liter on top, sorry. So let's correct this bottom then too. My bad, ladies and gentlemen. My bad, sorry. 1,000 milliliters on the bottom. I think you said that. I didn't write it though. All right. So when you're all done, ladies and gentlemen, what's your final answer here? What? Nope. Nope. Look at the number you began with. Now remember, we have to multiply by what number? 1,000. It's the only number on top that's not a 1, right? But what do we divide it by? What? 1,000. What's 611 times 1,000 divided by 1,000? The number doesn't change. Meaning every decimeter cubed is actually a liter, ladies and gentlemen. But again, the process that we went through, the way we did this, cancel out your units until you get into the unit that you are looking for. Then we do the math. 611 times 1,000 times 1 times 1. You want to do the times ones? I don't care. Doesn't matter. Not going to change anything, correct? Divided by 1 times 1,000. We end up with 611. Questions? Okay. Now, This next one, ladies and gentlemen, I have a conversion factor here for you again. We're going to use this conversion factor, but we need to cube everything. So what is 100 cubed? How many zeros in the end? 6. So that gives us 1 million, by the way, ladies and gentlemen. Unit of centimeters becomes centimeters cubed. What happens to the number 1 when we cube it? Stays 1. What happens to meters when we cube it? I was hoping that wouldn't be the hard question of the morning. What happens to the unit of meters when you take meter times meter times meter? What? Meter cubed. Thank you. Okay, now we can use this, ladies and gentlemen. What goes on top? What goes on the bottom? 1 meter cubed goes on the bottom. And actually, that's the place where you want to begin. Why? Because we need this unit here to cancel out with this unit here. So begin with what's on the bottom. On the top, we put the 1 million centimeters cubed. Okay? 2, 4, 5. Let's put the right number of zeros, 6 zeros. Okay. Now, I didn't give you anything else here. But again, we're still trying to get this into so many liters. Well, we're in the unit of cm cubed. What do we use next? What's our next conversion going to look like, ladies and gentlemen? Okay, what, where?
Milliliter on the top.
1 milliliter on the top. 1 cm cubed on the bottom. If you're wondering where I got that from, I got it from right here. I got it from right here. That still can be used. This and this cancel out, okay? So to get to liters, what's our last conversion look like?
1,000 milliliter equals 1 liter.
Okay, what goes where?
1,000 on the bottom.
1,000 milliliters go on the bottom. 1 liter goes on the top. Now, how you do the math from here is entirely up to you, ladies and gentlemen. Here's the way I would do it. I'm going to cross out 3 zeros here. I'm going to cross out 3 zeros here. Unit of milliliters and milliliters canceled. My answer is in the unit of liters. I take my number 250 times 1,000. $250,000 liters, ladies and gentlemen. Questions? Now, these were the hardest 2 problems on the entire worksheet, okay? But they still use the same basic principles we did on all of the other problems, which is if 2 things are equal to each other, I could put either one on the top, either one on the bottom, and I could cancel my units. And again, I keep working until I get to the unit that I want to end up in. I need to end up in liters, so I have to make this a 3-step problem to get to liters. All right? All right? Now, technically, if you want to say 1,000 cubic centimeters equals 1 liter, that's correct too. And then you could take this part out, because if 1 milliliter equals 1 cubic centimeter, 1,000 milliliters equals 1,000 cubic centimeters. Different ways of doing the problems. As long as you're doing them correctly and setting them up correctly, you will get credit for it. Even if maybe you use a different conversion than I do. Questions? All right. You need your computers right now, ladies and gentlemen. You need to get into the part that is the, into your EISN, please. So that is where I need you to be right now. All right. So here is where we left off last week on Friday. Okay. This was the slide that we were on. This is what we were talking about. Now, at the end of the hour, I think I gave you enough time so that you could hopefully copy this down. If not, you need to start copying it down right now. Okay. Again, we talked about how when scientists make a measure, they evaluate both the accuracy and precision of the measurement. Okay. Accuracy and precision are two different terms that often get confused. Okay. Accuracy is how close you come to hitting a target, how close you come to a known value. Okay. Now, there are certain things that there are known values for: boiling points, melting points, freezing points, density, specific heat. The density of water is 1 gram per cubic centimeter at room temperature. So if you go back into the lab and you measure out a certain amount of water, its volume, you find its mass, you should come up with a mass that is equal to the volume in milliliters, so that you get 1 gram per cubic centimeter, or 1 gram per milliliter. Those are known values. Those are targets. You cannot determine accuracy without a target. Okay? Second part is what is called precision. Now, there are two different ways of looking at precision. There is precision for a group of measurements. So I ask this row right here to go and measure the height of this door, to measure the width of your desk. I give you a meter stick. You give me 4 numbers. Those numbers should be very what to each other? Close. So we could talk about the precision of your measurements, how close they are to each other. That's one way of looking at it. The second way is how sharp a measurement is. Okay? So if someone gives you a number 13 centimeters and somebody else gives you a number 13.0 centimeters, 13.0 is sharper than 13. It goes further beyond the decimal. Okay? So that is another way of looking at precision. The problem is precision ends up, for a measurement, being determined by the instrument that you choose to use. So when you grab an instrument, ladies and gentlemen, each instrument has a certain precision to it that you need to determine. We're going to show you how to do that today. Questions? Okay. So let's look at this. Okay. How sharp a measurement is, how far it goes beyond the decimal point. All right. So in this set of data, just these 4 numbers here, which one of these numbers goes the furthest beyond the decimal point? A, B, C, or D? C. Okay? So the most precise measurement in that yellow set is C, because it goes 0.349. So that is what we are talking about when we say how sharp a measurement is. It goes 3 places beyond the decimal. This one goes 1, this one goes 1, this one goes 2. This is the sharpest because it goes 3 places beyond the decimal. Questions on that? Okay. So, set 2, the blue set. Which one is the sharpest measurement there? Which one is the most precise measurement there? Why?
It's for that, like it's for numbers after the decimal.
Okay. Again, A and C only go 2 places after the decimal. B, 3 places after the decimal. D, 4 places after the decimal. D is the most precise measurement there. Okay? D is the most precise measurement there. Now this orange set gets a little bit tricky. And it gets a little bit tricky because of something we haven't learned yet. When you have zeros at the end of a number and there is no decimal, do those zeros matter? That's the question. Do zeros matter if they're at the end of a number but they are to the left of a decimal? The answer is, in science, they sometimes matter. Okay? So in reality, of the 4 numbers up there in the orange set, the one that is the most precise is actually letter C. Why? Because I know this 3 matters. I don't know that these zeros matter, this 0 or these zeros matter. And again, this is a little bit ahead of where we're going. We will get to be able to explain that to you. But let's take a look at the last set, because these are all decimals. Now, these, there were no decimals in these numbers. When they're a decimal, these zeros at the end, they definitely count. So of those 4 numbers in D, or in the green set, which number is the most precise? Which number goes the furthest beyond the decimal point? A. Anybody for B? B? I'm sorry, B as in boy? Okay. Anybody for C? Anybody for D? How many are you picking, Jules? All of them? A and D are both the correct answer. A and D both go 4 places beyond the decimal. They are both the same amount of precision. This one only goes 3, doesn't go far enough. This one only goes 1. These are the most precise measurements. Questions on that? Okay. So now, ladies and gentlemen, now we've got 2 sets of numbers. Now we're looking at precision the other way. What I mean by the other way is how close together these measurements are. That is what we are looking at, okay? So we want the measurements that are as close together as possible, okay? So here's the way it works for this one, ladies and gentlemen. Hold on, sorry. I didn't want that. I wanted this, okay? And I want this. All right. So what we do for this one, ladies and gentlemen, is this. We find the highest number in set A. Which one is the highest number? 12.6. Find the lowest number in set A. What is it? 12.1. We subtract those two. The difference is 0.5, correct? Set B, which one is the highest number here? Highest number. Finley, what do you think? Of these 4 numbers, which one is the highest? Okay, good. Give me the lowest of these 4 numbers, Itzel. Good. These have a difference of 0.788. Which ones are closer together, ladies and gentlemen? Set A or set B? Set A. That's precision the other way. These are 0.5 apart. These are 0.788 apart. These are more precise. These are closer to each other. Questions? All right, set C. Which one is the highest number in set C, Sam? 4223. What is the lowest number in set number C, Giselle?
4.9.
All right, so that is a difference of 24, correct? Good. All right, highest number in set D, Skylar. Highest number, largest number. 38.020. Good. Lowest number in set D, Evelyn. 12.303. This has a difference of 25.7 something. I don't need to go any further. As soon as I knew 25, which set is closer together? C. Now, again, if I'm comparing these 2 numbers, which one of just these 2 numbers is more precise? Which one goes further beyond the decimal? This one, right? But when we're looking these as a series of measurements, we want the ones that are closer together. Take a minute, ladies and gentlemen, figure out set E and set F. Which one is the closer one? You got paper if you need some scratch paper to figure it out. Figure out which one is closer, set E or set F. Adriana, biggest number in set E. Which one is the largest? Do you have it on your computer though? Okay. All right. Albert, which one is the largest in set E? 0.230. Okay. Which one is the smallest in set E? Which one is the smallest, Aiden? Okay, good. In set F, which one is the largest here? Which one is the largest here, Theodore?
15.87.
Check again. The largest.
16.2.
Not a problem. 16.2. All right, Zach, which one is the smallest?
I cannot see that.
Okay, so here's what amazes me, ladies and gentlemen, and I'm just going to point this out. I got 2 seats open right in the front, and you can't see my board? That's poor seat selection, okay? Either that or you got to... This same slide is in your notes, ladies and gentlemen. What slide number is it in your notes? Somebody, please. 9?
Wait, no.
No. Anybody? 32. Thank you. This is in your notes. So when I ask you to bring up your notes, the reason I'm asking you to do that is, yeah, I know this is sometimes hard to see from where you're at, but this is also in your notes, okay? This is also in your notes. Estefani, can you find me the smallest number in set F?
14.99.
All right. Okay, so here, ladies and gentlemen, 0.08. Here, ladies and gentlemen, we have 1.21. Which one is the set that is closest together? Set E. Set E, ladies and gentlemen. Questions? All right. Here's your EISN that I shared with you, ladies and gentlemen. Precision and accuracy. If you go to that, I'm sorry, those are not included in yours. Sorry. My bad. That's completely my bad. Either that or I have them out of place, way out of place, because I did some rearrangement. Okay. I'm sorry. That's why, no wonder why you guys were looking at me like I was crazy. Sorry about that. Okay. Sorry about that. That's my bad for you guys. I will get those put in there for the next year, but that's my bad. Sorry about that. All right. So that was precision. Questions on precision. All right. Let's talk about accuracy real quick. The easiest way to talk about accuracy is with archery. Okay. Archery is the easiest way because you should be aiming for what portion of the target? The center. So that first person, do they have good accuracy? Can you tell their precision? You cannot because there's only one arrow. Precision would be they would all be close together. Look at the picture on the right-hand side. Are they accurate in the picture on the right-hand side if they were aiming for the center? No, they weren't hitting the center. But they are what? Why? Because they're all close together. You can have precision without accuracy. Okay? All right. So here again, what can we say about this person on the next slide? How would we describe their accuracy and their precision? How would we describe their accuracy? They are both accurate and precise. Why? Why are they accurate? Because they hit the middle. Thank you. Because they hit the middle, they are accurate. Why are they precise? What? They're all right next to each other. In the last photo, they were right next to each other, but they weren't near the middle. They were precise but not accurate. All right, describe the last one on the right-hand side. What would we say about their accuracy? Not very accurate. Why? Thank you. And that's the key. They're nowhere near the center. That's all accuracy is. How close you came to your target. How is their precision? Good or bad? Bad. Why? They're not very close together. All right, anybody in here ever go miniature golfing? Really, that's it? Only a few? Get out, people. Get out and go miniature golfing. Here's the world's toughest miniature golf course, ladies and gentlemen. And 4 friends went golfing. Okay? Now, in golf, what does it mean if the first column is what is called par? What does that mean for golf? In terms of what we've been talking about for the last few minutes, what is par in golf? It's your what? It's your target. Yes, it's your target. Now, ideally in golf, you want to get the lowest score possible, correct? But they realize that it's probably not possible for you to make it in one shot every single time. Probably not even 2 shots. So par is what would be considered the average for a good golfer, your target, what you should be shooting for. Okay? So keep that in mind. So par for 9 holes is 36. For this 9 is 36. The total is 72. All right, so Jim, let's begin with Jim's accuracy. If this is his target, 72, and he shot 104, describe his accuracy to me, Ray. Is it good or is it bad?
It's bad.
Okay. Now, Ray gets to make this opinion, too. All I'm asking for is good or bad. I haven't told you, well, it's got to be within this to be good, right? But obviously, it's poor accuracy or bad accuracy. Why?
Because it's way above 72.
Correct. It's way above 72. Way above, right? Okay. Now we need to go back and we need to look at Jim's precision. For precision, I want you to look at his score on every hole. Okay? Look at his scores on every hole. Finley, what do you notice about Jim's scores on every hole? So what does that mean for precision? It's good. Since his numbers are close together, almost all 6s and 5s, that is good precision. Now his accuracy is not good because he's not near 72. But they're 2 different things that we're looking at. So now we go to Cindy. Look at Cindy's scores on each hole. Jules, how are Cindy's scores on each hole? Are they close together or are they far apart when you look at each of her scores? So 8, 3, 7, 4. So what is it? Okay, so what does that tell you about Cindy's precision? It's bad. Okay. And again, we're just using 2 descriptive terms, good and bad. All right, what about Cindy's accuracy? Alicio, what about Cindy's accuracy?
It's not that bad, actually.
What do you think?
It's not bad. It's not as bad as James.
Okay. 20 out of 72, is that quite a ways off though?
It's bad.
I would agree it's probably bad. Okay? And again, you get to make a judgment. When you start talking about numbers, you know, what's close and what's not. That's kind of your judgment. But if you're supposed to shoot 70 and you're off by 20, that's probably not real good, right? All right. Let's go to Victor. Look at Victor's scores on each hole. Okay? When you look at Victor's scores on each hole, Karina, what do you notice about his scores on each hole?
Consistent.
Okay? Which means which one of these is good?
Precision.
Precision. Good precision. 3s and 4s on every hole, maybe a 5 in there once in a while. Okay, good. What about Victor's accuracy? What about his accuracy, Estefani?
It's good.
Why?
It's right next to 72.
Yeah, it's a 73. That's right next to it. Good. Okay. Last one, Susie. Look at her scores here throughout. Look at her scores here throughout. Sam, what do you say about Susie's precision? Back. I agree. 2, 8, 7, 3. Not good. But what do you notice about Susie's accuracy? What do you notice about Susie's accuracy, Elsa? It's very good. 72, right on target, right? Okay. So look at your options down here. What does this tell us about precision and accuracy? Can you have both?
Yeah.
Sure, you can be precise and accurate, can't you? Can you be good at one and bad at the other? So the two of them, while we can look at both, just because you're good at one doesn't mean you're going to be good at the other. Just because you're bad at one doesn't mean you're going to be bad at the other. There are two different ways of looking at things. Okay? People get these confused. They will start talking about how accurate something is when really they're talking about how precise it is. And in science, it matters. It makes a difference. Questions? All right. Here's a rule for you. Whenever you take a measurement, you are required to estimate one place beyond the precision of the instrument. One place beyond it. Okay? Now, here's what I mean by places, ladies and gentlemen. Going back to some basic math here. Every one of these digits is a different place in this number, correct? So this whole thing is one number. But it is made up of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 different digits. Okay? Every one of them is in a different place on the number line. Okay? Every one of them is in a different place on the number line. When you get to the right-hand side of the decimal, we have tenths, hundredths, thousandths, 10,000ths. On the left-hand side, we have ones, tens, hundreds, thousands, 10,000, 100,000s. Now, I do not like, ladies and gentlemen, writing out these names. I do not like writing out tenths. So instead, I will do this. Point 1. I do not like writing out hundredths. Instead, I will do this. 0.01. It means the same thing, right? We're talking about a place in a number line. Thousands. Okay? So understand, I don't care if you write it this way. I don't care if you write it that way. Doesn't matter to me. I prefer this way. How do we write tens? How do we write the tens place? Somebody, please. 1, 0. After the decimal, before the decimal, correct? Okay? Ray, count by 100s from 100 to 1,000.
Wait.
Count by 100s from 0 to 1,000.
So like 1, 2.
No. Hundreds.
100. Am I doing like
And what's the next hundreds?
200, 300, 400, 500, 600?
Good. 700, 800, 900, 1,000, right? Okay? Count by tens. From 0 to 100, shining. Count by tens. We'll stop. You're doing good, right? So when we talk about hundreds, we're talking about 100, 200, 300, 400, 500. Tens, 10, 20, 30, 40. Ones, 1, 2, 3, 4, 5. What about tenths? What about the tenths from 0 to 1? Alicio. Good. Okay. So when we take a measurement, ladies and gentlemen, instruments read in a place. They read in the ones place. They read in the tens place. They read in the tenths place. We got to figure out what place that is. Because the rule says once I know what place it is, now I can go one beyond that. I can go one beyond that. So if my instrument reads to the ones place, 1, 2, 3, 4, 5, I can give you a measurement to the tenths. I can do 2.4. I can do 2.5. I can do 2.6. Okay? And then as a person who looks at the measurement that you make, I know what place your instrument read to. You remember the 3 things I told you all measurements show? What's one thing shown in every measurement?
Units.
Unit. What else?
Quantity.
Quantity.
Is it accuracy and
Not accuracy.
precision?
And uncertainty. Well, that's how I know precision. If you report a number as 2.5 centimeters, the instrument that you used read to the ones place. That's why you went 0.5. I can tell the precision of the instrument you use by looking at your measurement because you're only allowed to go one place beyond the precision of your instrument. That's it. One place. Now, just in case you've never heard this before, ladies and gentlemen, chemistry is basically a set of rules and things. But for every rule, there is always an exception. So chemistry is a set of rules, and for every rule, there is an exception, and there's no exception to that rule. Here's your exception, ladies and gentlemen. Digital instruments. You go and you read a balance. It shows you a number, 12.445. You write down that exact number. You don't get to estimate one more place. A digital instrument, you write down exactly what a digital instrument shows you. Don't take away zeros at the end. If it says 12.200, don't make it 12.2. You've changed the precision of the instrument you were measuring with. Do not do that. Write down exactly what the instrument says. Exactly. Digital instruments have made life so easy, ladies and gentlemen. So easy because all you got to do is copy down the number. But you will be amazed how many times people don't copy down the 0 at the end of a digital instrument. And they make the instrument less precise than it is meant to be. Don't do that. Don't do that. Okay. To find the precision of the instrument, you find the number place on the instrument where all consecutive values are shown. Every consecutive value is shown. Each measurement used has its own precision and markings that are 2, 5, or 25. Do not increase precision. Why? There is no 2's place on the number line. There is no 5's place. There is no 25's. Now, they may help you estimate, but they don't improve precision. So here's what you need to do. You need to get up, you need to get with a partner, and you need to get to one of the lab stations in the back right now. Go. No more than 2 people at a side. Hurry up. Hurry up. Hurry up. Hurry up. All right. Come on, let's go. Let's go. Let's go. Sam, pick up one of the instruments at your desk and hold it up. I don't care which one. All right, so we're looking at this one, ladies and gentlemen. What instrument is this, by the way? This one. What's this called? A what? Come on. You guys are high school juniors and seniors. Thank you. A graduated cylinder. All right. So what I need you to do, by the way, what is the purpose of this yellow ring at the top that none of yours have? Anybody? It is there for this reason and this reason only. If you knock your graduated cylinder over, that ring is there to protect the top so it doesn't break. So if you decide to take and slide it down to the bottom so that it's out of your way, when you knock this over, you will now break the top possibly. So please leave this up near the top. Now yours don't have them. I'm sorry. I gave you ones that didn't have them because I don't have enough to do. All right. So when you look at this, ladies and gentlemen, what place, now by places, tens, ones, tenths, hundreds, thousands, what place is this instrument marked out in? In other words, what numbers can you find all the consecutive values for? Take a look at it. What place is it marked out in? What? Ones. On your instrument, find 13. Now find 14. Okay. Here is 13, ladies and gentlemen. This line right here. Where is 14? The longer of the lines above it, not up to 15, correct? This is 14, right? So here's 13, 14, 15, 16, 17, 18, 19, and so on, correct? So what place is this instrument reading in? What place is it marked out in? Ones. Meaning if you were to use this instrument, ladies and gentlemen, if it reads to the ones place, you can go to the what place? To the tenths. To the tenths. Now, if you'll notice, there are marks between 13 and 14, correct? What does each one of these marks represent? How much? How much does each one of those marks represent? Not tenths, because there's only how many marks? Count again. Between 13 and this longer line here, 14, how many marks? So what does that represent? How much? Point what? Anybody? Point what? Oh, you're close. There are 4 marks there, and you're forgetting about the 5th mark being the next line. How much is each one of those worth? 0.2. Thank you very much. Okay? So, this first line over 13 is 13.2, 13.4, 13.6, 13.8, 14.0, correct? Now, is there every tenth marked out there? 0.1, 0.2, 0.3, 0.4? Well, those marks will help you estimate. They do not improve the precision of the instrument. Meaning, this instrument reads to the ones place, your measurement goes to the tenths. Now, you may easily estimate where the tenths is because of the 0.4 mark, the 0.6 mark, but you don't get to go and do 13.5 something. 13.5 is as far as you can go. That is the precision of that instrument. Okay, Albert, pick up another instrument for us. All right, we got a beaker, ladies and gentlemen. Okay, we got a beaker. Take a look at the marks on the beaker. And tell me what place, again, tenths, ones, tens, hundreds, thousands. What place is this instrument reading in? What? 100s. You've got 100, 200, 300 on the side, correct? By the way, why is one side going up and the other side going down? See how you got 300 at the top and 0, 200 on one side, 100, 100 on one side, 200? Why are the numbers going up on one side and down on the other? Any idea? If you were to fill it with 300 and then start pouring some out, you can measure how far you've poured, how much you've poured out. It's just there for you. Now, there are marks in between 200 and 300, aren't there? How many marks? How many marks between 200 and 300? 3. What is each one of those marks worth? Oh. 25. Now, is there a 25's place on the number line? No. Can you find where 110 is on here? Can you find where 120 is? 130? Okay. Then this is reading to the 100's place. So if you were to measure something out in here, what place could you report that measurement to if this reads to the 100's place? What's one place to the right of 100? Somebody?
Can be quiet.
Yeah, they are. You might
They
as
are
well.
very quiet.
What's up?
Do you want the right side or left side of that case?
I don't care. I don't have anything doing it yet. So.
Okay, I just want to
Whatever
give
you
my
wanna do.
lab assistant a job.
Yep.
Okay, thank you.
Somebody give me a 3-digit number that is in the hundreds place.
Wait, would it be in the 1,000 place?
Nope. But you're close. Give me a number that doesn't end in zeros. 500 and what?
45.
That is the 100's place, correct? What place is 1 to the right of it? Jules, you went 1 to the left.
The 10th place.
The tens. So if this instrument reads in 100s, what can you report your answer in? The tens. And you are estimating where that number is. You are estimating where between 200 and 300 it is when you read this instrument. And you are allowed to estimate it. And your estimate may be different than the person who is standing next to you. Shining may look at it and she may say that's 270 milliliters. And Skylar may look at it and say, no, that's 260. Don't argue, you both can be right. Because you're estimating that place. There's no mark for it. You're estimating where in between two marks it's turning up. All right, give me another instrument. Give me another instrument, somebody. All right, Jules wants to do this one. This is called a pipette, ladies and gentlemen. This measures the volume of very small amounts of liquid. Matter of fact, the largest amount of liquid that it will hold is how much? When you look at your numbers. If it holds none, we're in trouble.
I said 9.
Oh, 9? Really?
No, or whatever.
Yeah, on one side again, you have numbers that go down from 0 to 9, right?
Yeah.
But it stops up here, doesn't it?
Yeah.
On the other side, they go up from 1 to what? To 10.
Oh, yeah.
Okay? And actually, then you get -1, -2, -3. The idea behind this is you pull liquid up to a mark on here, transfer it over into another container, and then let it out. So the reason it only goes down to 9 here, this last bit, is 1 more milliliter. So you would release 10 milliliters in there. Okay, so you can clearly see 0, 1, 2, 3, all the way to 10, correct? Are there any marks between 1 and 2? 8 and 9, 7 and 6? What do you think? How many marks are between there? How many? So what are those, what place is that? What? No. Remember, there is no fives place. Tens, ones, tenths, hundreds, thousands. That is tenths. That is tenths. So when you look at this instrument, ladies and gentlemen, my numbers aren't showing up very good here. Here's 7, here's 8. Here's 7.1, 7.2, 7.3, 7.4, 7.5. All the way to 7.9. All of the tenths places are there, right? What place could you report a measurement to with this instrument? What's one place beyond the tenths to the right?
The left, 100.
Hundredths. Hundredths.
100.
So we are talking about a number like 545.0. What's one more to the left? That is the hundredths place. That's the precision of that instrument. You remember the beaker? That we were precise in the hundreds place, right? Now we are precise to the tenths. Which one is a more precise instrument to use? The pipette. The pipette. This one will give you a number like 10.41. Your graduate or your beaker will only give you a number like 520, 310. Okay? More precise instrument. All right. Last one, ladies and gentlemen. You've got a ruler there that has two sides in it. Put it so that it is the side where you are reading centimeters is up from 1 to 30. Okay, so clearly the ones place is there, right? It goes from 1 to 30, correct? What are the little marks between 5 and 6? Which? Go ahead, Jules. Not 10, not thousands,
100.
not hundreds. And you might be saying it, but I'm not hearing it correctly from you, Jules. Tenths. With the TH at the end. And then maybe what you were trying to say, but
Yeah.
0.1, right? Okay, good. So that's what each one of these marks is, 0.1. So if you were to use this instrument to take a measurement, what place would it go to? It would go to the hundredths. One beyond the precision of the instrument. One beyond the precision. Now we flip it over, ladies and gentlemen. What place is it marked off in, the big numbers?
The 10. No, the 100.
Oh, you're close. Where you're getting confused is your tenths with the TH
10.
and your tens without it.
Tenths.
This is in tens, 1 0. 10, 20, 30, 40, 50, right?
Yeah.
Those are the numbers. What are each of the little marks here now? The ones place. The ones place. So what place would this instrument record a measurement to if you were measuring in millimeters? Oh, it's in the ones. You go one beyond that, you get to the tenths.
Tenths.
So because this is the ones place, you can go to the tenths. Okay? Have a seat, please, ladies and gentlemen. Okay, so here's what we mean, ladies and gentlemen. I got 30 seconds. This card is between 70 and 80, correct?
Yeah.
We could probably say it's between 76 and 77, correct? So you get to estimate where between 76 and 77 you think that measurement is. You get to say 76.1. Somebody else gets to say 76.2. Somebody else may say 76.0. That's what you're allowed to estimate. Have a great day, ladies and gentlemen. We'll see you tomorrow. Goodbye, goodbye, goodbye. Don't lose your phone.